Our next talk is a bit of an experiment. So we have Marco Valtis, who's been with ThoughtWorks between Brazil and North America for a little over 12 years now. He's been part of our technology leadership team, contributed to the technology radar. He's partnering with somebody who unfortunately couldn't be here live, so you'll see the video spliced in. Mark Richter, also long-term thought worker, been here about 11 years, part of our internal tech ops group. And it's a really interesting collaboration because Mark has helped us internally at ThoughtWorks manage our cloud costs through FinOps type techniques. And Marco is part of a relatively new attempt in North America to explore the intersection of technology and green cloud, green ops, partnering with Mark to see the intersection of FinOps and green ops. So very fascinating to hear the talk. So please welcome Mark and Marco.
Thanks, Brandon. Marco and I have put together what we think is a pretty interesting talk about the subject of cloud cost optimization and also optimizing for carbon footprint in the cloud. And as we'll see as we go through the talk, they both leverage some of the same principles, which is how we get to this interesting combination. Marco and I have both, as Brandon indicated, both been to ThoughtWorks quite a while. I'm in the tech ops side, internal IT. Marco is part of our green tech team and working with the team that developed Cloud Carbon Footprint. And what we want to do is present three concepts today. The first one is FinOps, or management of cost in the cloud. The second is GreenOps, which is a very similar thing, but it's managing the carbon footprint in the cloud. All cloud resources run in data centers. They consume electricity and energy. The type of the source of the power to a data center has a lot to do with how much greenhouse gas is implied by the use of cloud resources. So we want to go through that. And then I will wrap up by bringing both of these together into something that I've referred to as sustainable ops, which is the idea of optimizing for both cost and carbon at the same time. So let's get started here. The culture of FinOps and GreenOps is one of continuous optimization of what we're doing in the cloud, of all of our workloads in the cloud and the resources we have deployed. And when you have this culture, you develop what I think of as a flywheel effect of continuous optimization to bring down both and mitigate both greenhouse gas emissions and cost. And something that I think is an interesting thing to prove that I believe is possible is that being greener is not necessarily more expensive, which is sort of the popular view out there. Cloud is very critical to businesses, but unlike conventional data centers, it has a very, very different consumption model. Number one, it's decentralized. And engineers are actually completely separate from finance. So the purchasing of cloud resources and compute resources is totally different. Anytime anybody logs into the cloud and provisions things, they're making a purchasing decision and executing on it right there on the spot. The second is that the cloud operates on a variable cost model. So simply put, you pay for what you use. So the principle is minimize what you're using all the time. And third, cloud is scalable because resources are available on demand, and consequently we can minimize our cost all the time, and when we need more resource, it's available on demand. FinOps is an evolving financial management discipline of managing cloud resources. And the idea is to, rather than think of cloud as a cost center, which in the good old days of a data center, IT was thought of as cost. With cloud, I think we want to think about this as, a platform upon which to get business value. And so we want to help all of the stakeholders, software developers, finance, executives, product owners, and so forth, work with each other and collaborate to optimize their use of the cloud and think about it as a way to grow our companies and get business value from what's being consumed in the cloud, as opposed to simply spending money on computers and networks and so on and so forth. And third, the whole thing is data driven. So access to accurate and timely access to accurate data about our cost and spending in the cloud is fundamentally important to doing FinOps right. So I want to talk about the principles of FinOps. First of all, we talk about collaboration. And collaboration involves all of our stakeholders. So we have finance, who's worried about cost. We have software developers who are worried about the quality of their software. And we have product owners who are worried about interacting with stakeholders and users of the software and the functionality. And then we also have executives who are worried about, the financial health of the company. We talk about ownership, which is that every single user of cloud resources needs to be held accountable for their cost and their consumption. And this is a critical thing to ensure that cost and resource consumption is optimized, because if people are held to a budget and people are held accountable for what they're spending, then they're going to be much more aware of what's going on, and they'll optimize, for their own uses. Third important principle is what I call the driver. And the driver typically is a centralized team that oversees things that are best done centrally. And there are a few of these. One is ensuring that collaboration is happening, essentially touching base with the various stakeholders and making sure that communication is flowing well. Secondly, a centralized team is best positioned to negotiate cloud cost rates with the cloud vendors, to manage committed use discounts at a global level, and so on. That's where you really get a lot of leverage out of managing shared cost across the cloud. Third, we're worried about timely reporting. So key to all of this, as I mentioned previously, is this is a data-driven process. So accurate, timely data about cost and usage of cloud resources is fundamental. And fortunately, all the cloud vendors provide fairly good APIs for being able to capture this information, and then feed it into your favorite report model, reporting system, and provide visualizations and reports to the user community, which follows right into the fact that, as I said, it's a data-driven environment because we want our decisions to all be data-driven. And finally, we want to put ourselves in the position of being able to exploit the variable cost model of cloud computing. So at ThoughtWorks, this is what we mean by FinOps is data-driven. We're looking at a multi-cloud environment of GCP, AWS, and a bit of Azure. We're pulling cost and billing data from them into BigQuery, and we're using our tool Cloud Carbon Footprint to generate estimates of carbon emissions from all three cloud platforms, and we're pushing that up into BigQuery. So Google BigQuery then becomes our central location for all of the cost and usage and carbon emissions estimates to feed our decision-making process. So let's talk a bit about FinOps per se. the FinOps maturity model is fairly simple. Crawl, walk, and run. And it doesn't really matter how specific you want to get into each one of these categories. The idea is to get started and then build on what you have. And you can more or less define for yourself what crawl, walk, and run is. There's also a valuable resource to help you down this path. The FinOps Foundation exists and has a lot of resources about FinOps, and a lot of people there to collaborate with to provide advice and so forth. The second aspect of this is the various personas around FinOps. One is the FinOps practitioner themselves. I referred to this on another slide. I called it the driver, but it's the same person, and that's the centralized team, the person who's sort of coordinating and looking over the whole situation and making sure that information is flowing freely and collaboration is happening. And of course, we have executives and business owners and product owners and software engineering and operations that all have different stakes in the cloud. We can also think about different domains of FinOps, things like performance tracking and benchmarking, coming up with sort of baselines of what things ought to cost us, given the different kinds of workloads that we're running in the cloud. Real-time decision-making is part of this, and this gets back to timely and accurate cost and usage data from the cloud. We really need, it's not good enough to wait for the monthly billing statement from the cloud vendors. We want to know on a day-to-day basis what's happening. I've actually, personally experienced several situations where we noticed spikes in spending on a particular project in real time over a day's time, and we're able to quash that spike in spending by alerting the project team and taking action. So real-time decision-making is really fundamental here. Cloud rate optimization, continuing to work with the cloud vendors to get the best rates for for the deals that you have, and to manage committed use discounts and things like reserved instances on AWS, committed use discounts on GCP, and so on. Cloud usage optimization, and then organizational alignment is really important. Traditionally, software engineering and finance have very different ways of looking at the world, and keeping those in alignment is really key. Phases of FinOps. So this is a continuous loop, and you're running the FinOps phase loop all the time. The first aspect is to inform people about the cost and usage of their cloud. And this is all about visibility and allocation of cost. Yeah, and second is to optimize, which this is the phase where you're actually doing work in the cloud, tuning applications, moving workloads around to optimize for cost and later for carbon. Third is operating the environment on a continuous basis to maintain the efficiency that you have deployed, and so on and so forth, and then back around the loop again on a continuous basis. It's a process of continuous improvement, and this is the core of what I call the flywheel of continuous optimization and the culture of optimization. And you'll want to have some key performance indicators to be able to measure success. And here's a list of them, depending upon what your use of the cloud is. This list may be a little different, but it's important to establish some KPIs to measure progress against. And as we'll see in Marco's presentation in a minute, This is important for both FinOps and for GreenOps. So you want to have cost KPIs and carbon KPIs. Finally, here's an adoption roadmap, and this is straight from the FinOps Foundation for how to implement and roll out FinOps. Essentially, you have to start slowly. In order to build the culture, it's important to have early communication with everybody involved, to find who the stakeholders are, get them together, talk about what the objectives are, and establish, you could call it governance, you could call it a steering committee for overseeing the operation of the FinOps project or initiative that we're running. And this ensures that all of the key stakeholders stay in alignment and committed to the whole program. Very, very important. And so now I would like to introduce my friend and colleague, Marco Valtis, who will talk about GreenOps.
Thanks, Mark. So I'm going to introduce to you the concept of GreenOps. And before we start to dive into that, let's at least look on why you would want to bring GreenOps to your organization. So the first reason that you want to bring GreenOps to your organization is basically climate change. If you look on those two quotes, you can see that the numbers of our carbon footprint of our industry and the project numbers are very big. So there's an urgency to act in terms of carbon footprint, and our industry is a big part of that. The other reason you want to bring a GreenOps teams is that the same phenomenon that happened with FinOps, which was when you migrated to cloud, your cost decisions shifted back to the software teams. That same thing happened with emissions. So now software teams that have not all information are making decisions around cost for the whole company. Same goes for the emissions. And the point we're going to talk here is how GreenOps will differ from FinOps. They have the same similar reasons to introduce that into your company. Let's start with a quick definition of GreenOps so we are in the same page about what it's about. As FinOps is a data-driven discipline, but and the definition is quite similar, but the only difference between those two disciplines are what they are optimizing for. So FinOps is optimizing for cost, and GreenOps is optimizing for carbon intensity. And you're totally fair to think about, well, there's a very small difference between those two, so you can come up with a reasoning that is in the lines of, well, they're so similar that, which is the first statement here, that if you're doing FinOps, you're automatically doing GreenOps. Or maybe the second reasoning here, which is that, well, they are very similar. They are about optimization, which is true. So you just need to tweak a little bit FinOps, and then suddenly you're doing GreenOps. And what I would try to convince you is that the change of the optimization goal of those teams fundamentally change how those teams work. The definitions are similar, but the goals and how they will proceed about achieving those goals are very different. So let's tackle the first statement. We have here a map. Not sure if you can see that it's a map. It's very white here. But there's dots, and those dots are Amazon AWS regions. You have the same distribution for our cloud providers, but let's use Amazon here as an example. So each dot has a color, and the color represents on how intense is the energy production, the carbon for energy production on that region. So as dark the dot goes, that's more carbon intensive. As green the dot goes, less carbon intensive. And now you handle the task of, yeah, I need to cut my emissions. And I have these regions for AWS what I can choose from. a good reasoning would be, well, if I take my workload from the US region and move maybe to Canada, I'm cutting my emissions. And that's a fair statement if you're taking into account just this map. But there's a catch, and the catch is there's different prices for the same services in different regions. So the question now turns out to be, well, I can cut my emissions by changing where I run my workloads, but how much that will cost me? Will it be cheaper? Will it be more expensive? What is the financial impact of that decision? In order to study that, we can plot the emissions of those regions and the cost of a fixed set of services. Here we are doing a kind of simulation of using a certain company size, a small business that has a bunch of services running on AWS, and the numbers like how much it will cost you to run those services for a month. So right off the bat, looking at that graph, you see that the correlation is not obvious. If there is a correlation at all, it's not a straight line. So you cannot infer from the cost what the emission will be. And to highlight that point, I highlighted two regions here. First, US East, and then EU North. So let's make an experiment here. Let's say that you want to cut your emissions. So you move your workloads from US to Europe. As you can see on the table, you're going to cut your emissions for a factor of 45. But your cost will rise about 6%. So now you have to consider the trade-off. Well, I can cut by 45-fold, but I will pay a little bit more. And the crux of this insight is the first one I want to give you is that the mental model is reducing costs does not necessarily reduce emissions. And that's one of the reasons why the optimization goals that are different from FinOps to GreenOps are so impactful, and you cannot ignore that distinction. So I want you to keep that in mind, that just talking about optimizing costs does not necessarily mean that you're reducing your emissions. And that takes care of the first statement. They are not exactly the same thing. You cannot ignore your carbon emissions, just do FinOps and look at the cost and assume that you're doing greener ops. Now, let's look on the second statement. So the second statement gives that, well, they are optimization cultures, therefore they are very similar, so you might tweak a little bit FinOps in order to achieve GreenOps. And the point I will make, let's try to see how much is this tweak, how marginal is this change. First, what you need to do when talking about carbon footprint is actually to measure your carbon emissions. And how you go about that when talking about data centers and cloud usage? Well, first, you need to consider what kind of energy is available where the data center is. Is renewable, is wind, is fossil. That has different impacts on the carbon generation. After that, you need to ask yourself, well, how efficient is the data center on that region? In order to understand that, there is a metric called PUE that I'm going to give you an example so it gets very clear. Imagine that a data center uses 1,000 watts per hour of energy. And it has a PUE that will tell you that half of that energy is used for powering the servers that actually run your work. So that means that if you measure your workload and you say, oh, I used 1 watt of energy, you need to assume that the data center used another watt of energy to cool the servers or do something else that is not actually the powering the servers. So your emission, your power consumption is about 2 watts and not just 1. So that's why you need to take into account how efficient is the data center. Narrowing a little bit down, you have to ask yourself which hardware I'm running on, because CPUs have different profiles of energies. They have different performances. They have a bunch of optimizations in terms of what they can run and how much energy they will use. So you need to know what CPU you're using and how that CPU behaves in terms of energy when it's idle, when it's 100% used. This will take care, if you count how long you're using the CPU, and in that data center will take care of a big part of your energy consumption. But then there's more. If you want to report your carbon emissions in a comprehensive way, you also need to take into account how much carbon was emitted when the hardware that you're using was produced. This is what we call embodied emissions. So you're using a hardware. In order to produce that hardware, carbon was emitted so you can use. So that goes into your account. And last but not least, you need a detailed usage of your cloud environment. You need to know as much detail as possible how much did you use of CPU, of memory, of storage, and so on. And mind that the only information that you actually get from the cloud provider is the usage. And where you get that information is from the billing statement. And that's the reality right now. Cloud providers don't have reporting that is comprehensive enough that give you the detail of how much energy you're consuming and how efficient is their data centers. You have to go to other sources of information in order to estimate that. And this, which is just accounting for footprint, is just the first capability that a GreenOps team needs to have, just to account for the emissions. Other capabilities as well, once you have that data needs to become information so you can produce some strategies on how to handle or what are you going to do about the optimization. What is the cloud carbon optimization strategies that you're going to implement in your organization? Not only that, GreenOps and FinOps needs to collaborate together because those cost and emission decisions they can be on the same direction, but they can be on opposite directions. And then suddenly you have the sustainability area of your company and the financial area of your company with different interests in competition. So an agreement has to be achieved there, what KPIs, what targets you're going to use. And in the other part of the organization, which is the software engineers and where culture comes in, the GreenOps team needs to educate those software teams on how to use carbon intensity on their own decisions. Because for now, developers, as we started this talk, they are taking decisions that have consequences on your emissions without having the proper knowledge how to do so. So the GreenOps team then becomes necessary to educate those teams. One way we can go about educating those teams is using the Green Software Principles. Those principles were published by the Green Software Foundation some time ago, and when you read them, they are kind of broad, they are not very specific, and it's hard to make, well, how those principles relate to my software decisions. So I'm going to use an example trying to make it a little bit more concrete. Let's use the principle of embodied carbon. So remember, embodied carbon is the carbon that you emitted when you're producing the hardware that you're going to use. Let's say your company has an app, a mobile app. And one of the architectural decisions of developing a mobile app or maintaining a mobile app is what devices you're going to support. Devices come every year. So you know that if you want some features on your app, you're going to use a certain amount of hardware of certain devices. And the architect needs to make a decision. The product needs to make a decision. Well, we're not supporting 10 years old cell phones because we cannot give them the same experience. If we are to support that that 10 years old application, that 10 years old device, we're gonna have more complexity in our code base. Backward compatibility is hard. We have to have different features and so on and so forth. And now you're talking about the cost of keeping that app. Well, let's say that you decide to be supportive of old hardware. What's the impact on embodied carbon now? Well, one thing is you're not pushing your users to upgrade the devices. You're extending the lifespan of those old devices because they're still useful. Not everyone needs to have the full experience that you need to provide. So with some clever programming, service degradation, you can provide a very optimal experience in one device, but a reasonable experience that is still useful in another device. And that's an architectural decision that has direct impact on the carbon emissions, because if users are not forced to upgrade, they will delay the demand for new hardware, they will delay the disposal of that hardware. Well, everybody has a grandpa or grandma that has that like 10 years old cell phone, and they don't need to be pushed to upgrade every year. And that's a way that you can think about the principles and how they relate to actually emissions. And from that point, I want to bring two other insights. So the first one is what we talked about, like calculating the carbon. Well, the first thing is carbon awareness involves data that is not available, at least for today, from the cloud providers. The group that is going to handle this data needs to know what the data is about, needs to keep that data updated, and needs to find a way to calculate that emission. And the second point is that certain optimization strategies, like making a decision if you're going to support an old device or not, are more involved than just looking on the resource costs. They have more steps. And that's a reality for almost every sustainability decision that you're going to make. There's the chain reaction. Those are complex systems. So for me, I don't think that's a marginal change. I think that's enough change that grants a team with certain skill sets to take care of that decision, that information, that responsibility. Okay, now let's say that you want to bring GreenOps to your organization. How you go about it? Well, it's kind of straightforward. GreenOps is nothing less than a team that is in an optimization cycle. So the first thing that this team needs to do is understand what is the target emissions of your company. Nowadays, companies need to report. There is regulations, there is commitments, public commitments. So this team needs to understand what is the overall goal in terms of emissions of the organization. With that in mind, it needs to gather data. And as we saw before, getting data might not be so easy, so trivial. After getting that data, it needs to turn that data into information so it can derive some strategies on how to reduce your emissions. And to choose from those strategies, you can use a strategy map, which is basically all the actions that are available to you. You can plot them against, like we manage technical debt, you plot against the effort and the cost to do so or other axes that you want to consider, and you pick up what makes sense for you. So in this example, we have down, we have shutting down servers. Believe it or not, there's a lot of development servers that keep on. They stay on throughout the weekend and nobody's going to use. So that's a way to lower your emissions and your costs. But then strategies start getting more and more complex. One is to bring green software principles to your organization, which, as we saw, is a little bit more complex. Other strategies is region optimizations, which is choosing a region that is powered for more clean energy. And that can go up a level that you can actually move from regions from time to time, because the production of energy varies on that region So sometimes there's more renewables, sometimes there's more fossil. So you can use that information to shift the load. That's something about like following the sun, following the wind. But in the end, the message I want to give you is that it's a balancing act. If you have your product teams, your software engineering teams, your FinOps, and your GreenOps, all of those need to collaborate and work out a balance. If any of those areas tilt that balance, you're going to lack something, or accountability on your costs, or accountability on your emissions, or if just FinOps and GreenOps are working together and ignoring product, you're ignoring your whole alignment on the product development. If you achieve that balance, it's what we call a sustainable ops. And that's what Mark will talk about now. With you, Mark.
Thanks, Marco. Very interesting deep dive in there into GreenOps. And so now what we want to do is we've talked about FinOps, which is management of cost in the cloud. And we've talked about GreenOps, which is optimization of carbon in the cloud. They both leverage, as Marco indicated, this culture of optimization. And so we want to introduce a notion of sustainable ops, which is using FinOps and GreenOps together and leveraging that flywheel of optimization to do it. We'll have a GreenOps team, we'll have a FinOps team focused on different technical aspects of doing this. But let's now think about cloud sustainable ops as a new evolving cloud management discipline and cultural practice that fundamentally enables us to get both maximum business value in terms of cost, but also mitigate carbon footprint at the same time. And that's the really cool part about this, because we can care about the health of the company and the health of the planet together. And then similarly to FinOps, we're doing this by helping engineering, finance, and business teams to collaborate on data-driven decisions, because at the end of the day, that's what this is all about, is data-driven decision-making to optimize. So what sustainable ops looks like is the process of both FinOps and GreenOps operating together. And they're very similar conceptually. So with FinOps, we're informing, we're optimizing, and we're operating. And with GreenOps, we're understanding how to calculate the emissions impact. We're measuring it, and then we're optimizing it. And that's a continuous loop. Just as with FinOps, GreenOps is a continuous loop. And so we can think about an adoption roadmap for sustainable ops that includes the addition of measuring baseline carbon emissions early in the process, so that we have an understanding of exactly what our carbon footprint is now. And at ThoughtWorks, we're actually using this to inform our work with the Science Based Target Initiative, or SBTI, and measuring our baseline carbon emissions for the purpose of actually making commitments about future carbon reduction and mitigation that we'll do. So finally, the point is that FinOps and GreenOps share this common culture of optimization. And the culture is the most important part of this to make it work. There has to be collaboration between engineering and finance and the product owners and executives about the importance of doing this and building it into your everyday operation in technology to build sustainable software. And there are plenty of tools out there to enable you to help you do this. And And it's this culture of optimization that I really want to leave us all with and thinking about. And with that, I want to thank everybody for listening to this presentation. I hope it's been informative. I hope it's been a little bit fun, and we'll answer any questions that you have. Thank you.